Okay, we're going to go ahead and resume the competition this morning. We have three more teams that are excited to present their projects. Up next, we will be having the Illinois Institute of Technology. Following them, the Florida International University team. And then we will be concluding with the University of Florida team. Like I mentioned at the beginning, we will be reviewing, the judges will be compiling the scores from the top teams in the ranking with respect to the written and the oral presentation. We will resume after lunch at 1 o'clock, and then we will be awarding the top 3 prizes for today. So at this time, without further ado, we're going to welcome the Illinois Institute of Technology team. They will be presenting specifically on transatlantic water engineering solutions and specifically on the Almendares River. And leading this team is Jorge and Matt and Ivan, and I'll leave them to it.
Hi, everyone. My name is Ivan Leonard, and I'm from the Technological University of Madrid.
I'm Jorge Warga, and I'm from the Illinois Institute of Technology.
And I'm Matthew Elstrom from Illinois Institute of Technology as well. Our project's on the cohesive solutions for contaminant removal and prevention in the Almendares Basin. Our main objective is to implement cost-effective, innovative treatment solutions to improve the quality of the Almendares River and the Venture Aquifer, and that's what makes up the Almendares Basin. We will be doing our introduction, and then we'll talk about fire remediation, landfill waterproofing, wastewater networks, economic analysis, and then a conclusion. And I'll turn it over to Jorge for the introduction.
Hi. Thank you, Matt. First, in the next slides, I would like to explain to you which are the main problems that Almendares River faces, which are the solutions that we propose to solve these issues. First of all, where is Almendares River? It is located in the north of Cuba, and it flows through the west part of Havana. It gathers the wastewater from several factories, neighborhoods, whose wastewater is not treated. So this situation leads to a very low quality of its waters. But this is not just the only problem. Approximately half of the population of Havana takes its drinking water from the Venta Aquifer. This aquifer is placed below the Almendares Basin, and both are connected hydraulically. What does it mean? That any pollution, any pollutant, any heavy metal that is poured into the Almendares Basin will filtrate and will reach the aquifer. And then when people from Havana take this drinking water, they will be also extracting all this pollution. And this is a real threat to their health. So there are many studies about the aquifer contamination, the pollution of these aquifers. And the main conclusion is that once an aquifer has been contaminated, it's really difficult, not just in money, but also in time, to decontaminate it. So the best solution is prevention. It's prevention before more than 1 million people will be enabled to take its drinking water from the Venta Aquifer. We have reviewed papers, articles, studies about the current situation of the Almendares Basin to understand the whole water set. I mean, we didn't want to just focus in a single problem or in a single point, but to understand all elements in the basin, the factories, the neighborhoods, the different pollution sources. So we could propose several solutions to solve this problem. So we have worked mainly in 3 main solutions that are the ones that are there. The first one is the filter remediation, the second one, the landfill waterproofing, and the last one, the wastewater network system improvement. Matt will start now with the first of these solutions.
Thank you. All right. So our first of 3 contaminant removal and prevention methods for the Almendares Basin is phytoremediation. Phytoremediation is use of living green plants for the removal, degradation, and containment of contaminants in soils, sludges, sediments, surface waters, and groundwater. A major pollutant of concern in the Almendares Basin is heavy metals. All heavy metals are toxic at high enough concentrations with ability to bioaccumulate as well. This stresses the need for removal from the water system. We'll use the phytoremediation technique to target the Mordaza River, the Cali 100 landfill, and the Cotoro smelter tributary. These all have heavy metal sources discharging into the river due to paint, electronic, tanneries, and smelting factories, as well as the leachate from the landfill. As indicated by the figure, these are ideal locations to help make the most impact of the spread of pollution due to their higher concentrations. And with success, we can target other sites. So fiber remediation has many applications. The uses best suited for the Almendares River will be for both surface water and soil. To begin, rhizophiltration filtration uses hydroponically cultivated plants to remediate contaminated surface water through absorption, concentration, and precipitation of pollutants. The giant duckweed was a hydroponic plant chosen to target the Mordaza River and the Cotoro-Smelto tributary. For one, it's very versatile. Not only does it find success in Cuba's climate, it can survive in a wide range of pHs and temperatures. It also can accumulate a variety of metals, many that are present in the river. In a lab test with a hydraulic residence time of 7 days, our removal rates of these contaminants range between 60 and 94%. The figure on the right further exemplifies the effectiveness of rhizofiltration with lead contamination in milligrams per liter on the x-axis and the amount of lead in milligrams per kilogram of plant biomass on the y-axis. The trend indicates that with higher contaminants present, the higher the uptake into the plant's biomass. Many of the other metal contaminants listed show similar trends as well. Below is a picture representing a flotation device. This is made of bamboo and used in a successful study of rhizofiltration in China. In order to keep the giant duckweed in the desired location near the heavy metal sources, a similar device will be used in Cuba. Similar to rhizofiltration, a suitable plant for Cuba's climate and contaminants present is chosen for soil fodder remediation. The Indian mustard meets these requirements. It will be planted between the river and the landfill in order to create a buffer for leachate and rainwater runoff before they reach the river. An advantage of the Indian mustard is its high biomass. The more biomass a plant can produce, of course, with a higher contaminant uptake. The Indian mustard can also accumulate a variety of heavy metals, even more than the giant duckweed. During a 14-week study from seedling to mature plants, removal rates up to 25% were achieved. The graph below shows an accumulation percentage of chromium, copper, cadmium, and lead, with the soil heavy metal concentration maintained at 200 parts per million in the soil. It's a great example showing the capabilities of Indian mustard accumulating a variety of heavy metals and concentrations higher than the surrounding environment. So much of the data provided prior it comes from laboratory testing. So a great question is, how does it really work in the field? A great example is in Hartford, Connecticut on a brownfield site. A brownfield site is an old industrial commercial site that has some form of contamination present. And in this case, it was in a transitional neighborhood with 2,800 parts per million of lead present on the lot. So they needed an economically viable solution that was also effective. So what they did was they used phytoremediation. They used Indian mustard, Sudan grass, and sunflowers. What resulted was successful phytoremediation of the land and for the community to use. And what I really wanted to highlight here was that it was in a transitional neighborhood, and it exemplifies the power of phytoremediation under similar economic constraints as Cuba has. In addition to the remediation success, phytoremediation also influenced community involvement such as local middle schools, high schools, and colleges. Involving Havana's citizens would make them more aware of the extent of pollution in the Almendares Basin and show them they can make a difference. This can form important public support for further cleanup action and solutions such as the landfill waterproofing and the wastewater network extensions. So the overall benefits of phytoremediation is it's inexpensive, it's aesthetically appealing, there's a diverse range of species to choose from. If one doesn't work as well, there's many other over 400 species to choose from. And just noted prior, there's community involvement. Reduction in pollutants is proven. It leads to cleaner, clearer waters, less contaminated fish populations, less heavy metals in the environment, and a healthier community. There's potential for farmland restoration. Any leaching from the Almendares Basin of the heavy metals onto the farmland could be taken up through phytoremediation, therefore increasing crop yields and profits. And lastly, there's extraction of accumulated metals. Almost 90% in copper can be seen to be extracted from the plant, and this can be reused and resold. One of the disadvantages of phytoremediation is that contaminant uptake can only be taken from where the roots reach. So this calls for a more extensive and more permanent solutions such as the landfill waterproofing and the wastewater networks. And I'll turn it over to Ivan for the landfill waterproofing.
Thank you. So, the Calle 100 landfill is a site for the disposal of waste placed right next to the Almendares River. We couldn't find any kind of information about any project for the construction or the operation of the site. But we found a lot of articles criticizing odors and other problems related to the landfill is causing to the population. The runoff from the landfill, leachate, is getting to the river and the and the aquifer, causing pollution. So we tried to think different alternatives, and we ended with a solution thinking about a low economic impact in the present, but in the future, and to expand the life of this landfill until we can check another better location. So our solution is based in 3 major units. The first is as simple as a soil embankment with a perfect waterproof hot style in the interior, ditches and pipes to collect the leachate out of the landfill. Also, this perimeter enclosure will be continued underground with a sand clay screen. And finally, all this water will be collected in a leachate pond. So nowadays, the rainfall will percolate through the waste and divide into 2 fractions. One will follow the topography to the Almendares River, causing turbidity and pollution. And the other percolates to the aquifer, causing the contamination of the aquifer and the upwelling waters. So, in the future, with our solution, this runoff will be caught in the leachate pond where we can make different treatments so it doesn't get harmful for the river. And also, the polluted aquifer will be divided for the aquifer with these screens, assuring the quality of the dwelling waters. Now, Jorge is going to explain how we fix the wastewater network.
Thanks, Ivan. The rest of our proposal is the wastewater network improvements. This is not as innovative as the first one of the filter remediation, but it's also really necessary. Because there is, in the Vento aquifer, there is a fringe that has even a higher vulnerability due to its consist or a karst geology. What does it mean? That any pollution that is poured here can reach the aquifer even faster than in other places around the basin. So we identified 2 main wastewater networks in this fringe that are Maria del Carmen network and El Cotorro network. Both of them has already the main collectors built, but they lack the connection mainly from the homes to the main collectors. They also have the wastewater treatment plants already built that are marking the map. So by connecting the homes to the main collectors, we estimated that around almost 40,000 homes will be connected to the wastewater treatment plant. And this will lead to the following benefits. First, there will be a lower amount of contamination in the Vento aquifer, as there will be lower pollution poured into the contributors of the Almendares River or the Almendares River. There will be also lower eutrophication in the Jarcito Rebelde reservoir. That is, there will be less algae in the reservoir, so the quality will be improved. And last, there will be also better environmental condition in the Almendares River banks along its way. Now Ivan will talk about the economic analysis.
Thanks. So to estimate the construction cost of our infrastructure, we made a price database for Cuba based in prices from Spain, USA, and other Caribbean countries we can relate to Cuba. Then we modified this price breakdown, basically increasing the cost of materials and equipment and lowering the cost of the labor to match the Cuban wage. Also, to estimate the cost in time, we apply a financial cost, and after all these costs were made, we increase another 10% to make it profitable to foreign companies to get these infrastructures done. So, we end with this kind of graph where we can see more amortization span in years means a higher cost higher total cost for the construction due to the financial amount, but less cost per home and year. This was very important because we need the assistance of the population, because in the model they will be paying this with taxes, so this has to be low as possible. Finally, the total cost of execution will be around $17 million, and with the estimated amortization years, around $46 million. The future remediation costs weren't estimated the same way because we can see it's a very low cost in front of the other infrastructure, and this means around $5 per home and year during the first 10 years, and around $3.50 the next 20 years in an amortization span of 10 years for the landfill and 30 years for the wastewater fix. We were satisfied with this number, thinking it's an affordable cost for each habanero to guarantee the safety of their drinking water supply and also restore the degraded environment of the Almendares River. Now, Maut is going to conclude the presentation.
Thank you, Evan. So to conclude, all three of these methods will be needed to significantly reduce the pollution in the Almendares Basin, with phytoremediation being the preliminary, cheaper, easier to set up step, and landfill waterproofing and wastewater network extension to follow. Together, they will improve the overall quality of the Almendares River Basin. There'll be decreased infiltration of pollutants into the ventral aquifer. It will be low cost per resident, and there will be possible economic returns, and this will lead to a happier, healthier community with the aquifer contributing to the drinking water and their livelihood. They can enjoy a safe and clean environment. And thank you.